Alright, 143 class, this is a example from your Chapter 2 review, problem number 25. It says a clock takes 7 seconds to strike 7. Alright, how long does it take to strike 12? Alright, assume each chime occurs at 6. So the easiest way to do this, in my opinion, is what I call the stars and bars method. So a star represents a chime, okay, and a bar represents the gap between the chime. Okay, so if a clock strikes 7, it hits, it strikes for the first chime, then there's a gap, and then there's the second, third, all the way up to 7 strikes. Now, if you count, there's 7 chimes, but there's 1, 2, 3, 4, 5, 6 gaps. And because the chiming takes no time, then that means 6 gaps takes 7 seconds. So what we can set up here is like a ratio. If 6 gaps takes 7 seconds, alright, then how long is it going to take for there to be, how many gaps is there going to be, and how long is it going to take for there to be 12 chimes? Alright, so down here I got a picture. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 chimes now, and you can see it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 gaps. Okay, so it's always one less gap than there is chimes. So the question now is, okay, well, if it takes 7 seconds for 6 gaps, how long is it going to take for 11 gaps? And you end up with this proportion to solve. So 6 times x is equal to 11 times 7, which is 77. And then you divide both sides by 6. So x equals 77 divided by 6. Then if I do that on a calculator, I get 12.833. Alright, and they would want you to round this to 2 places. So that would be 12.8. Oops. Too big of a eraser. 12.83. Alright, so that's the easiest way to do this problem is count the gaps rather than a lot of people see these are the same, so they just say, well, that's got to be 12. But if you count the gaps and use that stars and bars method, or just know that there's always one less number of gaps than there is chimes, then you can set this up pretty easily.